Ever wondered what lies beneath your feet? Not just a few feet of dirt, but thousands of kilometers deep into the very heart of our planet. What if I told you that we're living on just the thinnest, most delicate skin of a giant, multi-layered cosmic onion? Today, we're going on an epic journey to the center of the Earth, peeling back each layer to uncover the extreme pressures, scorching temperatures, and mind-bending materials that make up our world. So, buckle up, because things are about to get seriously deep. Our journey begins right here, on the surface, on the Earth's crust. It's the layer we know and love, the ground we walk on, the mountains we climb, and the ocean floors we explore. But here's a crazy thought. It's incredibly thin. Relatively speaking, it's thinner than the skin of an apple. The crust is divided into two types: continental crust, which is what our continents are made of, and oceanic crust, which lies beneath the oceans. The continental crust is thicker, averaging about 30 to 50 kilometers, and is mostly made of lighter rocks like granite. The oceanic crust, on the other hand, is much thinner, only about 5 to 10 kilometers thick, and is made of denser rock like basalt. This is the only layer of the Earth that humans have ever directly explored. We've drilled down a little over 12 kilometers, which is impressive, but it's just a tiny pinprick into our planet's massive structure. The pressure here at the bottom of the crust is already thousands of times greater than at the surface, but trust me, we're just getting started. Now, let's dive deeper, past the crust, into the Earth's mantle. This is the biggest and bulkiest layer, making up a staggering 84% of Earth's total volume. The mantle extends down for about 2,900 kilometers. Now, you might picture the mantle as a sea of molten rock, but that's not entirely accurate. It's mostly solid rock, but it's so hot that it behaves like a very, very thick, slow-moving liquid, kind of like caramel or super stiff silly putty. This slow, churning motion is called convection. Hotter, less dense rock from deep within the mantle rises, cools down near the top, and then sinks back down again. This gigantic, slow-motion conveyor belt is the driving force behind plate tectonics. It's what moves the continents, creates earthquakes, and fuels volcanoes. The pressure here is immense, reaching over 1,000,000 times the atmospheric pressure at the surface. And the temperature. It ranges from about 1,000 degrees Celsius near the crust to over 3,700 degrees Celsius at its deepest point. The rocks here are rich in iron and magnesium, and under these extreme conditions, they form minerals we'd never see on the surface, like perovskite and postperovskite. It's a truly alien world of immense heat and crushing force. Next stop on our deep Earth tour, the outer core. Brace yourself, because this is where things get really wild. As we cross from the mantle into the outer core, at a depth of about 2,900 kilometers, the world turns completely liquid. This isn't liquid rock though. The outer core is a vast, swirling ocean of molten iron and nickel. It's about 2,200 kilometers thick, and it's incredibly hot, with temperatures ranging from 4,000 to 5,000 degrees Celsius. That's hotter than the surface of the sun. The pressure here is beyond comprehension, reaching millions of times that of the surface. So, why is it liquid? Well, even though the pressure is insane, the temperature is so high that it prevents the iron and nickel from solidifying. This swirling, liquid metal is the secret behind one of Earth's most important features, its magnetic field. The constant motion of the liquid iron generates powerful electrical currents, which in turn create a massive magnetic field that extends far out into space. This magnetic field acts like a protective shield, deflecting harmful solar winds and cosmic radiation that would otherwise strip away our atmosphere. Without the liquid outer core, life on Earth as we know it simply couldn't exist. We've now reached our final destination, the very center of our planet, the inner core. At a depth of about 5,100 kilometers, we find a solid sphere of iron and nickel, about 1,200 kilometers in radius, roughly the size of the moon. Now, you might be thinking, wait a minute, it's even hotter here than in the outer core, with temperatures soaring to an estimated 5,500 degrees Celsius. So why is it solid? The answer is pressure. The pressure at the center of the Earth is the most extreme in our entire world. I am mind-boggling 3.6 million times the atmospheric pressure at the surface. This immense pressure is so great that it forces the iron and nickel atoms to pack tightly together into a solid crystal structure, despite the blistering heat. It's a concept called pressure freezing. Scientists believe the inner core is a perfect, or nearly perfect, crystal of iron, and it's not static. Evidence suggests the inner core is actually spinning, possibly even slightly faster than the rest of the planet. This solid heart of our world is a testament to the incredible forces at play deep beneath our feet, a place of unimaginable temperature and pressure that holds the key to the stability and protection of our entire planet. So, from the thin, rocky crust we live on, through the slowly churning mantle that moves continents, into the liquid metal outer core that generates our protective magnetic shield, and finally to the solid, crystalline inner core, at the very heart of it, all that's our Earth, a dynamic, layered planet, with each layer playing a crucial role in making our world habitable. The next time you're standing on solid ground, take a moment to think about the incredible 6,000-kilometer journey straight down It's a reminder that there's a whole other world, or rather, several worlds, right beneath our feet. We've only scratched the surface, and so many mysteries about the deep Earth are still waiting to be discovered. Thanks for joining me on this incredible journey to the center of the Earth. If you found this as fascinating as I did, don't forget to hit that like button and subscribe for more deep dives into the wonders of our universe. What other cosmic topics should we explore next? Let me know in the comments below. See you next time.